Okay. So Andrea multiplied 6.75 times 10 to the 6 and 0.2 times 10 to the 6, and she got 6.95 times 10 to the 6. Explain Andrea's mistake and give the correct answer. So if I'm annotating, I want to make sure I annotate that she multiplied this number, and she got, which means this was her answer. Well, the only way I can determine if Andrea actually made a mistake or what her mistake is if I actually do the problem myself. So one of the things you can do is 6.75 times 10 to the 6, parentheses, parentheses again, 0.2 times 10 to the 6, and punch this all in our calculator. Or if you remember the steps of the multiplication with scientific notation, is that we have to multiply first the initial factors. So 6.75 times 0.2, 0.2, and then we bring down our powers of 10. So when I multiply the initial factors together, I get 6.75 times 0.2, 1.35, times 10 to the 6, times 10 to the 6, bringing down our powers of 10. Because the bases are the same, we're going to add the exponents. So again, I bring down my initial factor, and I keep my base and add my exponents. So this is my final answer. So if I compare my final answer to her final answer, then I would notice that she did not multiply her powers of 10. So that would be the first part of my explanation. Andrea did not multiply her, initial factors. Instead, she added them. I'm just going to finish the explanation over here. She also did not add the exponents on her powers of 10. Okay, let's move on. Next question. Triangle ABC was rotated 90 degrees clockwise, then it underwent a dilation centered at the origin with a scale factor of 4. Triangle ABC prime is the resulting image. So the things I want to annotate would be ABCD, remembering that that was my first pre-image. It was rotated 90 degrees clockwise, so that means one turn to the right. Then it underwent a dilation centered at the origin with a scale factor of 4, which tells me to multiply by 4 to get the resulting image, the second image, triangle ABC prime. So what's actually happening here? I want to kind of paint myself a picture. All right, so we have triangle ABC. Let's say it's a right triangle. First, it underwent a clockwise rotation. So maybe it's sitting like this now. One turn, and then we had to multiply everything by 4, so we should ultimately have a bigger triangle. So some of your comments were, how am I supposed to complete this problem if I don't have a graph or coordinates? This is a conceptual problem, so the understanding of what's actually happening in the picture in our minds rather than actually plotting it on the graph. So the question is asking what parts of ABC prime, the second triangle, are congruent equal to the corresponding parts of the original triangle, the first triangle. So what parts are equal? Well, we know from our experience in transformation that we can talk about two parts of a shape, two properties, and that's angle measure and side lengths. Angle measures are the parts that will never change or that will change the shape. And we know that rotation and dilation do not change angle measures. So the only other parts that we can talk about would be the side lengths, and we know that those are now 4 times bigger. So what parts are congruent angle measures? Are still congruent in triangle A prime, B prime, C prime to the pre-image of triangle A, B, C. Okay, our next part tells us to compare the perimeters of ABC, the first triangle, to ABC prime, the second triangle, and explain your reasoning. Well, perimeter measures the distance around. So this side plus this side plus this side. So if I had to multiply everything by 4, then the new perimeter of the new triangle should be 4 times bigger. So the perimeter of triangle A prime, B prime, C prime is 4 times larger than triangle A, B, C, the pre-image. All right, next problem. Graph and label, okay, the given systems of equations on the coordinate plane shown below. And then there's one more part to this problem. What is the solution? All right, so there are a couple ways to put these on a graph. And that's the first part is asking me, so I want to make sure that I can put that onto the graph. So I'm going to do the work for the first equation on this side. And I'm going to do the work for the second equation on this side. So I have 2 options. I can use rise over run, or I can make a table of values. So I'm going to do both. The first would be to rise over run, which means I need to start here at my y-intercept and then use rise over run, which is telling me that my slope is to go up 1 and over 2. So that's one way. The other way is to then give some values to x, substitute them into the equation. So my first value for x would be 1/2 parentheses 0 plus 2, which means my first y would be 2. Then I would do it again, 1/2 parentheses 1 plus 2, which means the next point will be 1. 1/2 2 plus 2, which is going to be 1 plus 2, which is 3. And finally, my last point, 1/2 parentheses 3 plus 2, which is going to be 1.5 plus 2, which should be 2.5. Just double checking. 3.5. And we know that those halves are hard to put on the graph, but we're going to do the best we can. So if I go to my other side, I can also start with the y-intercept, which is going to give me the point 0, comma, -1. That's always our free point. And then here, because we can't see it, our slope is 1. Which means I can write the slope as 1 over 1, which means my rise over run will be up 1 over 1. All right. I can also make a table of values for this one, giving x the simplest values and plugging them into the equation. So I have -1, 0, sorry about that. I have 1 minus 1, which is going to give me 0, and then 2 minus 1, which is going to give me 1, and then 3